Okay, so we're going to come back to this, how we use identifiers and where we get identifiers. So uniqueness. We really want to make sure that when we have somebody gives us an identifier and somebody else gives us an identifier, if the identifiers match exactly, then that means that it's the same thing we're talking about. Right? Like if I gave you two names, you'd want to assert they were the same person. In the US, we talk about Jim Smith. Right? It's clearly not unique, Jim Smith. In fact, there's a Jim Smith Society, and they have conventions. 60,000 people come, and they all have a sign that says, "Hi, my name is Jim." So that's not unique, right? The same identifier, Jim Smith, applied to many different things. So there's ways to guarantee uniqueness. One is in context. If it's a UPC symbol, then the number has been allocated to somebody and they're guaranteeing their uniqueness, even though it's just a number. By design, that is a scheme that's based on DNS. So you own the DNS entry. You own, like, I own morphbank.net. So if I use morphbank.net in my identifiers, then nobody else is going to use the same thing. That's by design in the sense that we have to agree on that. I mean, I can make up any identifier I want, but I, as a member of the community, will agree that I will only issue identifiers for domains that I own. So that way, the whole system of domain names takes care of the uniqueness for us. So I manage uniqueness within my domain, and nobody else uses my domain name, therefore we get uniqueness. That's why LSIDs embed a domain name in them. HTTP, a domain name. There are other schemes that don't have domain names. UPC doesn't have a domain name, but they have an organization. And there's another one which is called UUID. A UUID is just a really big number. It's so big that, and if you use the standard way of creating it, they'll never in the history of the world ever be the same one generated twice. That's the idea. So it's sparseness. There's so many of them and so few are ever used that we're guaranteed that every time we make a new one, it's never been made before. Examples, UUID, I'll show you one because we just saw one. Here, see this mess over here, all that mess? I believe that's a UUID. That's the kind of mess that you have when you do use UUID. So they've combined LSID as a strategy for making an identifier and then thrown another identifier on the end, the UUID. So the identifier is a combination of a particular scheme called LSID together with another scheme called UUID, and they stick them together. It makes for really long identifiers. UUID is a great scheme. So UUID is used inside your computer. Microsoft relies very heavily on UUID for identifying stuff. And that way they're guaranteed that when the computer makes a UUID to identify something, that no other computer ever in the world will ever use that same ID to identify anything. So when you move data between machines, it's completely unique. You don't have to worry about it. So that's why Microsoft adopted it very early to say, we're just going to put UUIDs on everything. Now, the disadvantage of UUID, if you just use a UUID by itself, you can't figure out who it belongs to. You can't resolve it. You can't start with the UUID and find out anything about it. You can go to some service and you can say, do you know this one? But if they don't know it, they can't tell you anything about it. There's no structure. It's deliberately non-resolvable. You can't find information about it unless you know where to go. Whereas an HTTP, you have a hint there. The domain name tells you probably can go to that domain to find out something about this item. And let me show you another one down here that we had, which was the taxon ID. What's the structure of that one? They used an HTTP URI, there it is, and it looks suspiciously like a software structure, right? It's the domain plus WIKI plus something else. So that's a perfectly fine identifier, but I don't really like it very much, because a wiki is a very dynamic thing, right? So I interpret WIKI. I look at that and I say, I think they mean that they have a wiki site. And this is in the wiki site. And what I know about wiki sites is anybody can change the name of the page, which changes the URL. And how are you going to guarantee that it's never reused and that it always can be referenced if you're picking identifiers like that? So I'm actually violating principles, which I'll talk about in a minute, about what you should be looking at identifiers. But I'm suspicious that they've created a very fragile system for identifiers. I would like it better if it said /species/ right? Instead of WIKI, it actually said genus or species or taxon. And then they could take care of, when you presented it to them, they say, that's a wiki page, and go to the wiki page. Another problem with this strategy that they've given there is it encourages people who see it to make up new identifiers. I wonder if they have this genus and put it in, make up a string and say, well, that might work, which is a bad idea. Identifiers are created by the provider and not made up by the users. So there's several different kinds of identifiers that we've seen. This one is resolvable, right? If we have an active data set, one that we're actually changing and manipulating, and we want to publish a data paper, then the identifier of the data set is actually of a thing that changes. So that is not the right identifier to put in the paper, because the paper analyzed a specific data set. So typically we think about using some kind of version control, that at the point that we write the paper, we make some kind of a copy of that object and identify that. And then by version control, what we mean is that you will be able to find other versions of what is essentially the same data set. So if you wanted to know, you read the paper, you see the data set, now you want to find what's the current state of that data set, then there would be a service. You present the version ID to it and ask for the most recent version, and the service would be able to give you an identifier of the most recent version. Okay? So that's the right way to do it, is anytime when you, at the point of publication, you need to create this snapshot, this version that stays the same and never changes. And there's lots of ways to do it. You could do it by timestamp, or you could, other ways. So you can have an identifier on a thing that changes, like a data set that's changing. You can have an identifier on such a thing. Every time you look at it, it may be maybe slightly different in its contents, but it still is the same identified thing. That's like I could have a list of the stuff I looked at today. Well, tomorrow, it's still called the stuff I looked at today, but it's different, right? Because today is not today anymore. Okay, so uniqueness can be guaranteed by a variety of things, and it can be reinforced by encoding. So you take the information that you want to put in the identifier, like collection code and things like that, and instead of presenting it just as a collection code, you do a little encoding on it to make it sparse or make it opaque so no one can see what's in it. So it still is the same basic information, but you change it a little bit. So UPC, they want a reliable way of reading barcodes. One of the ways you do that is by making sure that most of the possible combinations are not legal. And even more, that maybe one error is correctable and things like that. So error correcting codes and stuff. So one of the reasons the barcode scanner sometimes takes a long time is because it's misreading the barcode. And it's trying again and again and again until finally finds one that's right. And then it will beep. Right? So that's a built-in reinforcement to uniqueness by making sure that lots of codes are not used. What we can't do, however, is ever guarantee that we won't get two identifiers for the exact same thing. And this is a very hard concept that everybody hates it. I want one identifier for this taxon, and everybody has to use it. You hear that a lot. Well, I'm a realist. I don't think I can force everybody in the world to do what I want. So what I say is, we'd like to adopt common identifiers, but at some point we are going to have to be realistic and adopt strategies which allow us to figure out when two identifiers are the same, represent the same object. So it's an ugly fact. We can't do it. A lot of people want to do it. They want to say, there's only one identifier for this specimen. If you want to talk about my specimen, you use that identifier. Somebody may use some other identifier. Then what are you going to do? Okay, persistence, again, refers to mapping of an identifier to an object. I create an identifier, and I say this identifier represents this object. I can never come back and say it represents something different. We're tempted to reuse them. In databases, primary keys are reused. That's okay. There's no problem. But if you're issuing an identifier, you have to actually remember that you used it and don't use it again. And the reason is simple, right? You go and you get some data, like I issue some information, somebody keeps a copy of it. I come back later and issue some new information, and somebody shows me the old stuff, and it no longer is the same object. I'm in big trouble because I can't tell when I have no information. So we can rely on something that's persistent. It's persistent, and we use this word carefully. We don't like it. There was a GBIF sponsored a task group on global identifiers, and I was on it, and we really tried to pick some words that weren't used for something else and that identified the characteristics. And persistent was like the best thing we could find. But people want to think that that means if I have an HTTP something or other, that persistent means that no matter when in time I present that to the web, I can always find the object. The object is always going to be there. But persistence doesn't imply that the object's going to be there. So when you ask about an object, you're going to get one of two answers. Here's something about the object, or there is no such object. And it's okay for there to be no object. There no longer is anything associated with this identifier. We may not even remember if there ever was. It can still be persistent. It doesn't mean you can get information about the thing that it's identified. It means that you can't get information about something else. Okay, so we don't mean persistence to say that something we're building now is going to be available 100 years from now. We just mean this much simpler idea of the connection. One of the best things about identification is the ability to make commentaries about things and be specific about what you're talking about. So any scheme for annotation of things must necessarily rely on identification. So I issue data, I export data with identifiers on it. When I get comments back, the identifier comes back to me so I know what the comment is about. Right, that's where the identifier, a big advantage of identifiers. So we are seeing a diagram something like this in the use of data. So at the top we have the specimen catalog. That's the primary repository of information about the object. The specimen catalog exports data to the portal where people go to get data. There's a lot of reasons why you need this portal in the middle. The fundamental one is that it can do it can make the data consistent. So there's a lot of things you can do to the data to make it consumable at the portal level that the people in the specimen catalog either can't or don't want to do. So if you have an EMU database, any of you using KEMU?
I have seen it.
It's used in a lot of big museums. you basically have very little control over how the data gets exported from KEMU. And most organizations who have adopted some tool don't have the technical support to, the idea would be that if you can get your data out in any consistent form, go ahead. Export it in somewhere that you can make sense of. And then the portal knows what you're doing and changes the data so that it's a more consistent form. So the portal does that. It also provides a search capability across all of the specimen catalogs that it imports from. So I'm going to talk tomorrow about what we're doing in the iDigBio project to create such a portal and to work with the specimen catalogs to get the data moving properly. Then two clients of this portal are users and analyzers. So the users look at the data and they comment on it. And the comments go back to the portal or directly to the user. Similarly, so all of these arrows going up represent feedback in the system. And the portal, you could really take away the direct connection from user to specimen and let all the data go back through the portal, all the commentary go back through the portal. So the portal developers and maintainers of portals are committed to providing that feedback link. And none of this works without identification. So if the specimen catalog presents data about, says, here's some data about a specimen. If they use a different identifier than they used the last time, I have to assume it's a different specimen, right? So the identifier is what's going to allow me to tell, in the portal case, what allows the portal to decide whether this is a new specimen or a new copy of one we already have. It's the identifier. Same identifier, what they mean is throw away the old one, here's a new one. Different identifier, it means this is different. Okay? And for instance, we might say if they're exporting everything, if they don't give us an identifier one time, then we get rid of the object because that's no longer, they consider that object to be gone. And it is something that might happen. A provider might issue a specimen with a single identifier and then come back later and decide that no, we want to issue a different identifier. If, for instance, the data in the original one was so bad that it was completely wrong, maybe even it was like, you had the specimen identifier from the catalog, but everything else about it was from a different specimen, the labels got switched, then they just want to stop that original identifier and say, no, that's not valid. That was just wrong. Here's an identifier that represents that actual object. So the portal would then delete the old object from the database. Now, okay? So in fact, a single specimen might, in its lifetime, have multiple identifiers for very good reasons. Because the identifier is really about the digital record of the specimen, the database record of the specimen, not the physical specimen. So we're identifying the record of the specimen much more than we are the physical specimen. So it could well have more than one identifier. Okay, the data was so bad that we're just going to stop. We're not going to use that identifier anymore. We're going to use a different one. So in any case, the specimen catalog exports to the portal. The portal maintains information from lots of catalogs. The users can go directly to the portal to do discovery and downloading of data, and the feedback loop goes through the portal. All of this works only because of identification. So it's just fundamental that the community needs to do identification properly. But it's also important to recognize that proper identification relies on unique strings, not on specific strategies. So somebody wants to do LSID, somebody else wants to do HTTP, somebody else wants to do UUIDs. Doesn't really matter to the portal because the portal just sees these as identifiers, strings. Okay, so I'm not saying that the community has to adopt LSID or HTTP or anything else. I'm saying that we adopt the principles of identification and the portal will be fine. It doesn't have to know exactly how to deal with your identifiers. So I don't advocate, I mean, we at iDigBio suggest a particular identifier strategy, but we're not that happy with it. And actually, a lot of people don't like it at all. Okay, so benefits of identification. Feedback, annotation, tracking, analysis and use, right? You can imagine that that paper could have had a reference to a data set, the paper on the taxon, on the species, whatever, the paper we were just looking at, could have had an identifier which represented a set of, a data set which were the identifiers of all the specimens that were used in the analysis. Take a snapshot of that list, store it someplace, put an identifier on it, put the identifier in the paper. Now we have a permanent, persistent record of exactly the specimens. All the specimens with identifiers and the set with an identifier. Then a paper published using, like we go to GBIF, we get a bunch of data, we have a data set, we store the data set, we publish the data set identifier. People who want to find out exactly where did all that data come from, it's all there. Because the identifiers can be resolved back to the portal can tell you where the data came from, and the portal then is potentially able to provide reports to the providers about the usage of their data. And that's one of the really big things that everybody wants. We want to tell our stakeholders how much our data is being used. And the current models just don't support it. You can't find, there's no, and it's not just technical, it's social too, right? Because we don't have the commitment from the writers, from the authors and the publishers to maintain that information through the publication cycle. And until people are willing to put it in their papers, then it's not going to be a complete cycle. All right, now, how do we make identifiers? There's a thing that is often called the Darwin Core triple. And unfortunately, I can't ever think of the name of the last piece. But there's an institution code, there's a collection code, and then there's a specimen number or something. Access number. It's some identifier that's unique within those two things. So the combination of those three things. And GBIF, up until recently, I don't want to say what's going on now, they always required that that every object has to have those three fields, and they have to be not null. And maybe there was even some consistency so that they wouldn't accept more than one with the same three values. And yet, GBIF went out and commissioned a task group to suggest how to deal with other kinds of identifiers because it really wasn't working. So the hope was that this is biology standards, right? If you have a collection, you have an institution code, you have a collection code, you have a specimen number, and that's how it's always been maintained in systematics papers, et cetera, right? So you were saying that in the paper, when they have a specimen, they give you some information about it. They try to identify it. Well, when you go outside of preserved specimens, it's very hard to justify using a structure like this. If it's an observation of a bird that's stored in eBird, they don't see it this way. They artificially can create these things, but it's not that natural. And the other thing is that identification is much simpler than that. I don't care what string you use. Put a string on this thing, put an identifier on this thing, and use it all the time. One of the problems that used to happen in the GBIF data was that people were creating this last value, the great unknown value there, XX, using the row number in an Excel spreadsheet. So if somebody reordered the spreadsheet, the next time all the numbers changed. So from one month to the next month, you couldn't rely on any mapping between the triples. Right? That's one of the problems that occurred, right? And of course, that's a social problem. That's a misunderstanding of identification. So now we have fields for identifiers. Put an identifier on the object. And those identifiers get carried around You can, if you like the Darwin core triple, you can guarantee uniqueness of that as well. If you want to throw the Darwin core triple into your identifiers, the domain name is the institution, the collection code is in there, and it's some kind of a path in your data, that's okay too. And, but you don't have to. You can use whatever you want. You can put UUIDs in, you can, whatever, right? It's okay. Barcodes, whatever you like, that's fine as far as GBIF is concerned. Now, they're interested in making sure that you know, there's there'll be some rules to apply here, but anyway, the Darwin core triple, as well established, it's very well established in the collections community, but unfortunately, it's not completely followed to the extent that we can rely on it very well. And there's a lot of cases where it just doesn't apply. There's a lot of stuff in MorphBank which represents specimens, but they're in somebody's desk, maybe. They're not really in a collection exactly. All right, so how do we, so we as providers have to put identifiers on our objects, and we have to remember what the identifiers are. Almost, this may well mean that you have to add an extra column in your database to hold identifiers. You may have to create a table of identifiers to hold all the identifiers that you're not currently using. Like as a provider, if I take an identifier and I make it deprecated, kind of no longer used, then if somebody presents that to me, I'd like to say, that object was full of errors, you might find it here, and give you another identifier. So I remember that it was an identifier, I don't just forget about it, and I tell you, I issued that identifier from this day to this day, I no longer use it, this is what happened, all of that information would be stored as well, and that would be kind of a good practice. So, but we have to choose, how are we going to identify things? Choose a scheme, HTTP, LSID, DOI, you choose a scheme and you stick with that, so that gives you a format for the strings themselves. So if it's LSID scheme, then every string starts with URN:LSID:. If it's HTTP, it always starts with HTTP://. If it's DOI, it always starts with DOI:. Okay? So that's the scheme. And these are registered with some international organization, and they're very controlled. So once you've chosen a scheme, the next thing you have to do is decide how you're going to make your identifiers. And it's very important that you be able to map your identifiers back to the objects. So if somebody presents an identifier to you, you have to be able to figure out which specimen that's associated with. So the Darwin core triple makes sense. Your museum is organized according to collections, and within the collection there are unique identifiers, unique numbers. So you could embed that in the URI. You could pick UUID. You could make some combination like LSID plus UUID. There's a UUID strategy that involves a domain plus a UUID. Seems like a sensible strategy because it gives you some idea where to look for the thing. So there's a lot of trade-offs. There are documents have been written about this, but as an organization, some decision has to be made about what you're willing to support. And when we look at whether there's visible information in the identifier or not, there's a trade-off. If the information is easy to see, the provider has a bit of an easier job in figuring out how to get to the object. But on the other hand, users look at it and think they can tell what it is by looking inside.
Vamos a repasar las diapositivas de la presentación, fijar los conceptos principales. Si hay algo que nos quede claro o que queráis aclaración o revisar, pues me paráis en el momento y resolvemos. Bien, este es el guión de la presentación. ¿Qué son y para qué son los identificadores? ¿Qué características pueden tener? Esas características más en detalle. Capacidad para resolver, esto es, para que programas, para que aplicaciones, para que los ordenadores puedan manejarlos y no solamente los humanos. Que sean únicos, que sean persistentes, identificadores en la gestión de las colecciones, web semántica y datos enlazados y servicios de resolución de identificadores. Un identificador, obviamente, algo que identifica algo con dos características, que sea persistente y que sea único. Persistencia en el tiempo y unicidad en un determinado ámbito. Una comunidad puede ser pequeña o grande, pero reconociendo el marco donde se utilizan esos identificadores. Como ya se dijo en la presentación anterior, ¿qué es lo que van a permitir los identificadores? Agregar información. Dos identificadores con un elemento de información, dos elementos con el mismo identificador referido a distintas piezas de información, agregan información sobre el mismo objeto. Y esto también lleva el concepto implícito de que un identificador no solamente sirve para identificar, sino también para crear servicios sobre ellos, servicios de resolución, servicios de anotación, por ejemplo. Ejemplos de identificadores: los códigos universales de productos, o los DOIs. Bueno, esto vamos a pasar un poco de prisa. Los DOIs son Digital Object Identifiers. Hay una entidad que los gestiona, tú pagas, obtienes tu identificador y que además de obtener tu identificador, esta entidad te proporciona servicios de resolución. O sea, tú puedes introducir el identificador, el DOI, en una URL y te va a decir qué hay detrás. Y bueno, como seguramente habéis visto, cada vez son más usados en el mundo de las publicaciones. En este diagrama un poco se puede ver qué tipo de servicios podemos esperar de los identificadores. Para trazar el uso, para control de calidad y también para redundancia. Beneficios. Se pueden utilizar para añadir información en forma de comentario o de reacción a algo. Trazar objetos o paquetes de información en su análisis y su uso y permitir la atribución de la información a su origen y otros. Voy a traer a colación una pregunta que antes hacía Estela, que era de, bueno, pero si tenemos ejemplares, tenemos identificadores de los ejemplares, ¿por qué tenemos todos esos identificadores además de localidades o de imágenes o de otro tipo? Pues precisamente para conectar esos elementos, para poder decir, bueno, de esta localidad, ¿qué ejemplares hay? O decir, con este nombre científico, ¿qué ejemplares he identificado? Etcétera, para poder ver la información desde múltiples puntos de vista. Bien, aquí estaba Greg haciendo énfasis en la estructura de Darwin Core, como la parte de la unicidad del identificador permanente era obtenida combinando tres elementos: la institución, la colección y el número de ejemplar dentro de esa colección, que fuera del contexto de las colecciones traía algunos problemas. Sobre identificadores y opciones que hay. Pues en esta diapositiva vemos que detrás de los URIs podemos encontrar distintos esquemas con ventajas y con inconvenientes. Casi mejor, Greg, you elaborate on this. What are the advantages and disadvantages of embedding information within the code, and then I continue on that.
But anyway, we said it's fine. So the idea is that if your databases are organized according to a collection and some kind of a primary key within the collection, then to expose and use that strategy for your identifiers makes it very easy for you when someone, that is the providers, software systems, when you get an identifier, you go to the collection, you go to the object in the collection, and that's the thing. But it creates problems when data moves or changes in some other way. Suppose some piece goes from one collection to another, then you no longer can find it by the identifier. So there are some minor advantages which I think turn out to be probably not worthwhile. No matter what you do, as a provider, you have to keep track of the identifiers you have actually issued. So you have to have some place in your database a list of all the identifiers. And if you have a list of all the identifiers, then it doesn't matter whether you can figure out what they mean. You just go to the list, you find in the list, and it tells you what it means in the database. So you could, basically I'm saying that it's probably not the best idea to embed information. And I could show you examples of image identification in which the file names of the images are a combination of the species name, the photographer's name, the day, these 70, 80 character long file names where they've tried to put all the information about the object into the file name. And I'm saying, let the camera name the file. Put the metadata someplace in a database rather than trying to have, I think you try to do that and it makes your life miserable trying to keep up with it. And if you want to find out how miserable, you should talk to Martin Ramirez in Buenos Aires about the 35,000 spider images that all have names like that. It was a tremendous effort just to figure out, just to make. So I think identifiers that carry meaning probably create more problem than they solve. So, and I think very nice, one good thing about adopting a system like Specify is that Specify is obligated to deal with these identification problems. So Specify 6 has an identifier scheme, LSID scheme, for instance, where you can ask it to put LSIDs on your objects, and it keeps track of them, maintains them, and does the mappings for you. So you can expect that in most cases, the software systems are going to do a lot to take care of this. And we were dealing with situations, for instance, in Symbiota, where they had not adopted a scheme and they wanted to know what to do. And we have a lot of discussion about it. Some people hate identifiers that start with H, like HTTP on the beginning of an identifier. But so I try to be kind of neutral. I see a lot of advantages and disadvantages of different kinds. The main thing is that as a provider, you have to commit to maintaining the connection between the identifier and the object it identifies. And you have to keep track of it somehow in the database. Is that good? Sí.
Para clarificar y resumir, una de las cuestiones centrales en el diseño de los esquemas de identificadores únicos es si dotar a esos identificadores de un contenido que directamente conecta con el objeto, por ejemplo, el nombre de la araña en una fotografía de la araña o no. Y Greg es partidario de que los identificadores que no tienen ningún sentido, ninguna relación de contenido con el objeto, tienen alguna ventaja sobre los otros. Pero hay discusión sobre ello.
I wish I could be more specific. To a certain extent, we're really just learning what all of this means in these collections. So let me talk a little bit about a few other topics, and then we're not too far from lunch, but we'll be on time. So back to linked data. Now this is the quote from the linked data site. Basically says the same thing as what I said before, that the idea is that associated with a URI, that is an identifier, will be some information that's presented in a way that can be aggregated and analyzed and used by computer agents. So not web pages, but rather some much simpler presentation. So linked data talks about it that way, but then initially the way they're implementing linked data is through HTTP URIs, that is, you have a domain name there and the thing can be used, you can use the HTTP protocol to, you can use the protocol to get to the information about the data. And they use these three tools: HTTP, identifiers, and RDF. So you have the identifiers, you have the HTTP protocol, and you have the RDF. Here's another example, a familiar example about why identifiers can be very difficult. There's a scheme called ISBN that is used to identify books, right? So a publisher issues an ISBN on a book. We know that they publish different versions of that book. So it might well be that they actually put different ISBN on the paperback, the hardback, the gold-covered one, whatever, the first edition, right? If you want to read the book, you don't care, right? All of those identify exactly the same object. You don't care if you get it on your Kindle, or you read it on the web, or you get it in paperback. The contents are the same. And in some sense, you don't care whether it's the Spanish version, the English version, they're all the same, right? From the point of view of the content of the thing, they're all the same. They all have different ISBNs. So sometimes you don't care about the difference, but if you're a book collector, you might well care about exactly what it is. You want the Spanish edition because you're more comfortable reading the Spanish edition. Or your set is not complete without the Romanian translation. So sometimes, in some contexts, you care very, very much that these identifiers are really different things, and sometimes they're the same thing. And that's one of the reasons why you can't really think there's a single identifier on any particular object. To give you one more example, if you have data in a specified database, you have an identifier on the specimen. If you export it to IDIG-Bio, we're going to put our own identifier on that, because our capture of that information has a lot of other information about it, right? It has who gave it to us, when they gave it to us, who can look at it, all kinds of stuff about the actual ingestion or capture of that object. Now, if you want the specimen information, that's as good the IDIG-Bio identifier is as good as the specimen identifier, because when you ask for it, you can get the specimen information. But in other contexts, you might find different providers that'll give you the same data. You could get it from GBIF, you could get it from IDIG-Bio, you could get it from the specimen catalog itself. Now those identifiers that identify the different versions, the different records, may make a difference to you. So figuring out as a user what does the identifier really mean is something that we are going to be working on for years, I think, to figure out all of what that means. Okay.